Summer's chemistry lesson video for section 15.1, and this is another short one. I know we don't have a lot of them, but this is one of them. So in chapter 15, we are going to start talking about aqueous solutions, but we'll go fully into solutions in chapter 16. So an aqueous solution is just a solution where water is the solvent. So a water molecule has a dipole moment because the oxygen is much more electronegative than the hydrogens. So oxygens have an electronegativity value of about 3.44, where hydrogen is only 2.1. So we can say that oxygen's partially negative, hydrogen's partially positive, so our dipoles would point towards the oxygen atom. And this strong dipole moment causes water molecules to have strong attractions for each other. These attractions are called hydrogen bonding. So we've discussed this all the way back in chapter 8. Hydrogen bonding describes many of the properties of water, such as the surface tension and vapor pressure. So water has a higher surface tension and lower vapor pressure than most other compounds that have similar molar mass because of their strong intermolecular forces. So this brings us back to surface tension, which I know we've already talked about. So the surface tension of water is high because of its hydrogen bonding. So those water molecules are just attracted by strong intermolecular forces with one another. The surface tension of mercury is even higher due to metallic bonding. So you've all seen where you'll put like a drop of water on like a counter or something and it kind of beads up like this. It beads up because of those intermolecular forces. Well, if you put mercury in a drop, it will literally become a sphere because it has even stronger intermolecular forces. Well, sorry, it has even stronger forces, which are not intermolecular at that point. It's metallic bonding. Okay, so the amount of intermolecular forces or bonding will determine the surface tension. So water is one of the few substances in which the solid state is less dense than the liquid state. So most substances, the solid is the most dense, liquid is less dense, and the gas is the least dense. But in water, water is more dense than ice, which is why ice floats, and ice is, of course, the solid form. The reason that ice floats in water is because of that difference in density. So why does that happen then? Because we always think of the solid as being the most compact. Well, the structure of ice is a regular open framework of water molecules arranged like a honeycomb. So we're talking like 6-membered rings here. And so the inside of those rings is just empty space. When ice melts, the framework collapses and the water molecules compact closer together, making the liquid more dense than ice. This is why in the phase diagram, the solid-liquid equilibrium line points towards the left in water. So this is what it looks like at the atomic or molecular level. So here we have all the dotted lines are hydrogen bonding that's being formed, those intermolecular forces. So here we have the liquid form, and so you can see just random hydrogen bonding is occurring. Once it freezes and becomes a solid, you can now see the honeycomb shape. And so that causes it to spread out to make these rings, whereas when it's in the liquid form, they can just be as close as they want together. So that's why if you leave like a water bottle in the freezer, then sometimes it'll explode or it'll like bloat up because the ice needs to form this honeycomb shape. So the honeycomb shape maximizes the number of hydrogen bonds between the water molecules. So, boy, that section went very long. So what causes the high surface tension and low vapor pressure of water? It is the hydrogen bonding. The hydrogen bonding. And then how would you describe the structure of ice? It has the honeycomb shape. Alright, so that's a little bit of background about water so that we can get more into talking about aqueous solutions in the next couple of sections.